This lesson will show you how to solve linear equations using the addition property of equality. But before we start that, I want to review a few things that you learned from Chapter 1. Do you recall, first off in Chapter 1, you talked about the difference between an expression and an equation. An expression is something of the form 2x minus 1. Whereas an equation is something of the form 2x minus 1 is equal to 5. An equation contains two sides that are equal to each other. For expressions, we can evaluate expressions, and you did this. For instance, if I wanted to find the value of 2x minus 1 when x is 3, then I can substitute the 3 in place of the x to get 2 times 3 minus 1, and then use order of operations, which would be 6 minus 1, or 5. So when I evaluate an algebraic expression, I will get a numerical value. An equation is something that we don't say is evaluated, but we say solve. So when we talk about solving an equation, we are trying to find the value of the variable, that makes the equation true. Find the value of the variable that makes the equation true. Now, in section 1.8, you actually had an equation and you were given a value and you had to determine, was that value the solution? Well, in this chapter, we're going to actually learn how to find those values that are solutions to the equation. And the first method that we're going to talk about is this addition property of equality. So let's look at what we are going to cover. We're first going to talk about how to identify linear equations. Then we're going to talk about using the addition property of equality. And then we're going to talk about simplifying equations and using the addition property of equality to solve those. So let's first talk about identifying linear equations. What is a linear equation? A linear equation is an equation of the form a times x plus b is equal to 0. And a, b, and c are real numbers. The main condition is that a cannot equal 0. Now another condition on this is, notice that x is our variable. And what power is it raised to? Well, if you recall from chapter 1, if there's not one explicitly stated, it's understood to be raised to the power of 1, right? Because we know that x to the first power is the same thing as x. So a linear equation is one in which the variable is raised to the power of 1. So that one that I showed on the last slide, 2x minus 1 equals 5, is an example of a linear equation. X plus 4 is equal to 2 is an example of a linear equation. 2x minus 5 times x plus 3 is equal to 7 times x minus 4 is a linear equation. Notice that in every instance, the power on x is raised to the power of 1. So all of these are linear. What is not a linear equation would be something like this. X squared minus x minus 6 is equal to 0. This has a power of 2 on the variable. This is called a quadratic equation, and we'll get into solving these in chapter 5. Okay? Or 1 over x is equal to 3. This is called a rational equation. We'll get into this in chapter 6. But here the variable is, you might say, raised to the power of 1, but it's in the denominator of a fraction. So that's called a rational equation, not linear. Okay? Now, let's talk about the addition property of equality because it's one of the very important properties that allows us to solve a linear equation, and in fact, any equation. The addition property of equality states that if I have two things set equal to each other, if A is equal to C, then the addition property says that if I add the same quantity to both sides, I get an equivalent equation. It also is true that if I have two things equal to each other and I subtract the same quantity from both sides, I get an equivalent equation. So the addition property of equality says that you may add or subtract the same number or the same expression, same quantity, from both sides of an equation to produce an equivalent equation. Okay? It's kind of like, if you think about scales, you're going to see here my artistic abilities leave something to be desired. If you have scales, old-fashioned scales, and each side has something on there that keeps it in balance. In other words, the quantities on each side are equivalent. Well, to maintain that balance, if you take something off of one side, right, let's say if you subtract B from this side, you have to subtract B from this side to keep it in balance. Or if you add something to this side, you're going to have to add something to that side to keep it balanced. So really what we do to one side, we have to do to the other is a way that you can say that. Now, why do we even need that? Our whole goal in solving a linear equation is that we're going to start with something of the form maybe 2x plus 4 to 7. And we're going to have to perform a series of steps to that equation to eventually come down to x is equal to some number. So that is, we want to produce a series of equivalent equations throughout our steps so that our final answer is of the form x equals a number. So basically we're undoing what all is attached to the variable x so that we can find out what that number is that solves the equation. Okay? So let's look at some examples. Your first set of examples in section 2.1 are basically just one step. That is, you have an equation, the variable is really just has a coefficient of 1, so all you have to do is determine what you need to add or subtract to get the variable by itself. So let's look at a few of these and see how that would work. So like number 5, it's x minus 4 is equal to 8. So we're going to treat what we really need to do, if you will, we have to think about what is attached to the variable x. What do we need to do to get rid of that thing that's attached to the x? So in this case, our x is subtracted by 4. So to undo that subtraction of 4, what we have to do is the opposite, which is to add it. And so if you note here, if we add 4 to the left by the addition property of equality, we also have to add 4 to the right. So notice what happens. The x minus 4 plus 4, well, those are inverses of each other, right? When we add them, they add to 0. And so what we're left with really is x plus 0, or just x, is equal to 8 plus 4, which is 12. So we're saying that the value that solves that equation is 12. Well, let's see if that works. To check it, plug it in place of the x. If we put in 12, the rest of that equation was minus 4. We're testing, is that equal to 8? 12 minus 4 is indeed 8. So we get 8 equals 8, which is true. So that means that the number we plugged in was the 12. Oops, let me get the right color here. 12 is the solution. So x equals 12 is solution this equation. Now, in mathematics, we have a way of writing that called a solution set. And so instead of writing it out like this, you're going to see it written in brackets. So just the number 12 by itself is called the solution set of that equation. Okay? So a number was subtracted from the variable x. Notice what we did. We added it to eliminate it from the left side. So let's go to one that involves like an addition. For instance, number 11. I squeeze it in right here. Number 11 is r plus 9 is equal to 15. So this time we've got to get this r on a side by itself. So that is, we need to remove this plus 9. Well, what will remove adding 9 is subtracting 9. So we're going to have to use that addition property equality to do something same side, and that operation is subtracting 9. So what we're left with now, notice r plus 9 minus 9, those are eliminated, right? They add to 0, so all we have is r is equal to 13 minus 9, which is 4. Now how can we check? We plug in the 4 in place of the variable. 4 plus 9, is that equal to 13? Well, yes, plus 9 is 13, so that equals the right side. So we know that the value r equals 4 is the solution. Or another way to write that is the solution set containing the number 4. Okay, don't put in the 13. 13 is just what each side reduces to when you evaluate it at the value 4. 4 is the number that made it a true statement. That is the solution to the equation. Okay? Now, it doesn't matter which side the variable is on. For instance, let's look at number 18. This 3 is equal to z plus 17. Let me back up for just a minute here, add a blank page. Okay. Number 18 is 3 is equal to z plus 17. Our variable happens to be y, but that doesn't matter. Our goal is to get the variable on one side, the number on the other. So if I want to get the z by itself, I've got to remove this plus 17. Well, what will remove adding 17 is subtracting 17. So we apply the addition property of equality to both sides, and we subtract 17. Okay? Because z plus 17 minus 17, those are eliminated. So we just get z is equal to 3 minus 17. Now here you have to remember all the rules about adding, subtracting sign numbers. Remember that 3 minus 17 is really the same thing as 3 plus the opposite of 17. So we're adding a positive and a negative number together. So we subtract and take the sign of the larger, which would be negative 14. Now if we check, 3, is that equal to negative 14 plus 17? Well, yes, right? Negative 14 plus 17 is 3, so that is true. So our solution set is the value that made it true, which was negative 14. Okay? So addition property of equality just says we can add or subtract the same number from both sides of the equation. Now, some of these problems involve variables on both sides, so let me illustrate that, but the goal is still to use the addition property of equality. As in number 29, it is 3p plus 6 is equal to 10 plus 2p. And these problems that I'm getting are from the textbook, section 2.1 exercise set. The difference here is that I have variables on both sides. Now, please don't invent new mathematics. I cannot combine 3p plus 6. Those are not like terms. I cannot combine 10 plus 2p. Those are not like terms. I need to treat the equation as two separate sides. Okay, and what I do to one of those sides, I have to do to the other side. So the first thing that I need to do is to get all the variables on one side. And the way I'm going to do that is use the addition property of equality to eliminate it from one side. So usually what we do is try to eliminate the one with the smaller coefficient. So if I'm looking at the coefficient here is 3, the coefficient here is 2, let's eliminate the smaller one, which is the 2p. So if I want to eliminate the 2p from the right side, notice that I have 10 plus 2p. The way to eliminate it is I have to subtract it. I have to do the opposite sign. So here, what I'm going to do, let me write this back in the original color, 3p plus 6 and 10 plus p. Okay, and we have an equal sign floating in there. So what we need to do now is subtract 2p from sides. Okay, so the first step is bring all the variables to one side, or think of it as eliminating it from one side. So notice what that gives us in the remaining step. The right side is 10 plus 2p minus 2p. Well, those go to 0, right? The 2p's do, so that right side just reduces to 10. On the left side, we can now combine some like terms. 3p minus 2p is 1p, or just p, plus 6 remains. So we have p plus 6 is equal to 10. Now we need to get the p by itself, so we've got to get rid of this plus 6. Well, the thing that will eliminate a plus 6 is, you guessed it, right, subtracting 6. So notice now our equation reduces to this, b to 4. So look at what we did. We had to remove the variable from one side. Then we had to eliminate the constant from one side. And our whole goal in doing that was that we had p equals a number. Okay. Now, do you trust your answer? You can always check. These are problems I say you get 100% on because you know immediately if you're right or wrong. So to check your answer, we plug in the value 4. We say 3 times 4 plus 6. Is that equal to 10? 2 times 4. Okay, right, so all I did is take the 4, go back to that original equation. Well, we know 3 times 4 is 12 plus 6. Is that equal to 10 plus 8? Yeah, right, 18 is 18. So that's a true statement. So that means that our solution is correct, and it is the solution set of 4. Okay? Now, let me show you some of these that have decimals or fractions. I can probably sense that those are going to scare you. So let's do a couple of those. Let me do number 32. Write it in a different color so you can see it a little bit better down here. It is 7.7r plus 6 to 6.r plus 6. Okay. So to solve this equation, notice we have a variable on each side. So we need to first start by eliminating one with 6.7r. So we need to eliminate the 6.7r. So what would we need to do to that right side to eliminate it? Right, 6.7r is positive. So to eliminate it, we need to subtract 6.7r. And what we do to one side, we must do to the other. So on the right side, we're left with just, notice that 6.7r's cancel or eliminated. We get 6. What is 7.7r minus 6.7r? Do you remember that with decimals, you just have to line up the decimal point? So notice we get 0, 0.7 minus 0.7 is 0. 7 minus 6 is 1, so 1.0, which is really just 1r, or r. So r plus 6 is equal to 6. So now we have the variables just on one side. We have to remove the constant. So to remove the constant of plus 6, we will subtract from both sides. Right, still all is using the addition property of equality. So notice that the 6 are eliminated. We get r is equal to 6 minus 6, which happens to be 0. Well, 0 is a real number, so that is certainly fine to have as your solution. And the way that that would check, notice if I put in 7.7 times 0 is 0, plus 6 is 6, so we have 6 on the left side. If I put in 0 on the right, 6.7 times 0 is 0, plus 6 is 6. So the value 0 makes both sides the same, so that is our correct solution. Okay. Now the other problem that I wanted to do was one that had a fraction. So let me create a new page and let's do number 34. Let me go in a blank page. Okay, but number 34 I think was 1/5 x Now, if you follow what I was saying before, notice here we have variables on both sides. So I was saying that we need to eliminate the smaller coefficient, right? The variable with the smaller coefficient. Well, negative 4.5 is smaller than 1/5. So we would need to eliminate the negative 4/5 x from the right side. Well, since it is negative, the way to eliminate it is to do its opposite, which would be to add. So if we take 1/5 x minus 7 is equal to negative 4/5 x, we're going to add 4/5 x to both sides. And in doing that, the right side is just simply 0. Another thing to worry about on the left side is that we have 1/5 x plus 4/5 x. Those are like terms, so when we add them, we can add their coefficients. But fortunately, they have the same denominator, so we simply add the numerators to get 5/5 or 1. So we really have just 1x minus 7 is equal to 0. Well, now we still have something attached to the x on the left, so we've got to get rid of this minus 7. The thing to get rid of subtracting 7 is to add 7. So we add 7 to both sides to get then that x is equal to 7. Okay? So our solution set consists of the number 7. The next few problems that we're going to encounter have some things where you actually have to simplify the side of the equation before you do the steps of solving or using the addition property of equality. So let's look at some of these problems. They look more involved, I will definitely say. So let's start with number 39. But if you remember your steps, the first thing you want to do is to simplify each side first. And when you simplify each side, you cannot cross the equal sign at this point. You are just simply looking at, like here's your equal sign, so you think of that as a stop sign right here. Combine this side and then combine this side. Okay? So if I'm looking at 5t plus 3 plus 2t minus 6t, I have some like terms there that I can combine. I have a 5t plus 2t, which is 7t, minus 6t is 1t plus 3. And that is equal to, on the right, 4 plus 12, which is 16. So these are going to come down to using the addition property just like the previous problems. Our first step just looks a little bit more involved. So now if I want to solve this equation for t, I've got to eliminate this plus 3. So what we'll eliminate adding 3 is, right, subtracting 3. So therefore we get t is just equal to 13. And you can plug it in both sides to check. Okay. Well, let's do a few more of these. I know those with fractions are probably concerning you, but let me skip those for just a minute. Let me go to number 47 because that reviews some of the things that we've talked about. Actually, I'm going to change that. Let me do number 49 because that has a little bit more involvement to it. Okay. Here's 49. It is 2 times p plus 5, 3. So the first step is to simplify the equation first. So on the left, notice we can clear parentheses. If you recall, the parentheses, if there's a number out there, you've got to distribute. Well, what's the minus sign? Remember that means the opposite, which is this multiplying by -1. So when we distribute, we get the equation 2p plus 10 minus 9 minus p is equal to negative, okay, because a -1 times a positive p is negative p. Now we can combine some like terms here, right? 2p minus p and p. 10 minus 9 is plus, and that is equal to -3. So to get the p by itself here, I've got to get this plus 1. So what gets rid of adding 1? Right, subtracting. So if I subtract 1 from both sides, I'm going to get the equation p is equal to -4. Okay? So my solution set is a set containing -4. Now, what do you feel about something like number 46? Let's look at that problem. And I'm not going to remember this really well, am I? 6/7 s minus 3/4 is equal to 4/5 minus 1/7 s plus 1/6. So let me see if I can remember that sum. 6/7 s, I'm not going to remember it, am I? Is equal to 4/5 minus, so 1/6. So our goal, first of all, is to simplify each side as much as possible. Well, this is where the ugliness comes into this equation, because notice on the right side, I have some like terms. I have this 4/5 plus 1/6. Well, to combine those, I've got to get a common denominator. Well, what is the common denominator between a 5 and a 6? The number that both 5 and 6 go into is 30. So 5 goes into 30. 6 times 4 is 24. 6 goes into 30 5 times 1 is 5. So on the right-hand side, we have 6/7 s minus 3/4 is equal to -1/7 s plus 29 over 30, right? Those are the same denominators, so we add their numerators. Now we need to get the variables on one side. We eliminate the smaller coefficient, So to eliminate a negative 1/7, we're going to add 1/7 to both sides of the equation. So if we add a 1/7s, notice the s terms are, so we just have 29 over 30. The left side simplifies pretty nicely here too. 6/7 s plus 1/7 s. 6/7 plus 1/7 is 7/7 or 1. So we really just have an s minus 3/4 is equal to 29 over 30. So now we've got to get the s by itself. To do that, we have to add 3/4 to both sides. Okay, so the 3/4 are eliminated. We just get s is equal to, now we have to find a number that both 30 and 4 go into. And I believe 30 and 4 both go into 60. Oops. So we have 30 goes into 60 2 times. 2 times 29 is 58. 4 goes into 60. 15 times 3 is 45. So we add them. They have the same denominator. We add the numerators. 58, 45 is 103. So 103 over 6 would be the solution to that equation. Okay? Now, the last few problems deal with given some expressions, write an equation, or given some, and then solve the problem. So this comes back to your skills translating that we did in Chapter 1. If you have 3 times the number, is 17 more than twice the number? Find the number. Well, the way I like to do this is to circle what represents your equal sign, because then whatever comes on the left side of that, or before it, is your left side of the equation. Whatever comes after the is your right side of the equation. So the left side of our equation is a number. Well, 3 times the number is 3x. Is, then we have to interpret what is 17 more than twice the number. Well, 17 more than means we're adding 17 to twice the number, which would be 2x. Okay, so now to solve it, we've got to eliminate the variable from one side. If we eliminate the smaller one, smaller coefficient, we have to get rid of a positive 2x. We do that by subtracting 2x from both sides. And so subtract 2x. Notice that on the right, those variable terms are eliminated, and we just have 17. 3x minus 2x on the left is just simply x. So our number is 17. Generally with the word problems, you write it out in words. Let's do another one of these. And about number 64, for instance. It says if 5 times the number is added to 3 times the number, the result is the sum of 7 times the number and 9. So here, what is or equal sign is the result is. Okay. Sums before that, if 5 times the number is added to 3 times the number, is our left side. What comes after that, the sum of 7 times the number and 9, is our right side. So interpreting the left, 5 times the number is added to 3 times the number. So here's 3 number, we're adding to that 5 times the number. The order of those don't matter because addition is commutative. The result is, there's our equal sign. Now we need to interpret the sum of 7 times the number and 9. Notice here, the sum in the operation, the word and separates what two things we're adding. So we're adding 7 times the number, which is 7x, and 9 together. Okay. So we would simplify 3x plus 5x is 8x is equal to 7x plus 9. Now we need to eliminate the variable from the right, so we would subtract 7x from both sides. If we subtract 7x from both sides, we get the equation equivalent to this, which is just 8x, right? 8x minus 7x is equal to 9. So the number that satisfies this problem is 9. So I hope I some issues from section 2.1. If you have any questions, please contact me. Thank you. Bye-bye.